In this video, we'll generate the Legendre polynomials over the values of x from -1 to +1. And we'll use the Taylor-Maclaurin series sum for the calculation of the expansion. We'll calculate the coefficient using multinomial and combine, and our value for k is 0 to n minus m. We begin with the values of n, which is data validation, list of items, 0 to 10. So our values of n will start from 0 up to 10. And our value for m will be data validation, list of items, 0, 2, 4, 6. So our values of m will be 0, 2, 4, 6. Now we can calculate the value of k, which is from 0 to n minus m, which is equal to sequence of n minus m plus 1 rows, 1 column starting from 0, incremented by 1. So that if our value of n is 2 and our value of n is 5, that's 5 minus 2 equals 3. Our k values will be from 0, 1, 2, and 3. Now we can use series sum. So array formula, series sum of our x value, so x minus 1. So the quantity x minus 1, x minus 1 over 2, raised to the power k, where our k starts from 0, incremented by 1, and the coefficient will be this range. And we'll complete the expansion formula. You have 2 more items, 0.5 times 10 to the minus m and 1 minus x squared raised to the power m over 2. So we begin with the first one. That's 0.5. That's negative 0.5 raised to the power m. Next, the second part, times the quantity x, 1 minus x, 1 minus x, no, 1 minus x squared. So x squared raised to the power m over 2. So m over 2. That's m divided by 2. Third. Next, we complete the coefficients. Begin with our factorial m times multinomial that's multinomial n comma m comma k. Our k is d3. So we lack the coefficients b, we lack d14, and the values. We don't lack the value of k because it's moving. Continue. The last term will be combine. See, combine n comma m plus k, which is d3, and we lack d14. That's our value for n, and b14, the value for m. We lack these references. And as we drag this downwards, you have an error. This should be empty. If this is empty, this should be 0. So we'll delete this. So if k is empty, if d3 equals empty and 0, otherwise calculate. So let's drag this again. So if this is empty, this should be 0. Now we can calculate this using, we can use the chart. We'll use scatter chart. It's a scatter chart and show the trend line, polynomial to the 10th degree. To the 10th degree, use the equation as label, and the legend will put it on the left. Use 16, we put it on the left. So here you have the trend line and the trend line equation, which is also the associated Legendre polynomial. So we'll calculate these coefficients using the LINEST formula. Before we do that, we calculate the 1 comma x matrix, which is equal to array formula of the x values raised to the power 0 to 10. Now that we have the 1 comma x matrix, also the PJ in a matrix, we can use LINEST data y and data x. So here we have the regression coefficients. We'll compare it with our polynomials. So we begin with the values of n equals 0 and m equals 0. So at n equals 0, our polynomial equals 1. 1x to the 0. N equals 1. Polynomial equals x. At n equals 2, polynomial is minus 0.5 plus 1.5 x squared. N equals 3, that's minus 1.5 plus 2.5 x cubed. Now we start with 0, with 2. M equals 2. Start with 0. There's no data because it is n should be greater than 2 or equal to 2. So even at 1, so we have to use 2. So it should be greater than or equal to 2. At n equals 2, it's 3 minus 3x squared. That's 3 minus 3x squared. N equals 3. Our polynomial is 15x minus 15x cubed. At 4, that's minus 7.5 plus 60x squared minus 52x to the 4th. Now we go to m equals 4. M equals 4, it's 105 minus 210 plus 105x squared. So minus 210x squared plus 105x to the 4th. M equals 5. That's 945x minus 1890x cubed plus 945x to the 5th. This completes the use of multinomial, combine, and series sum data validation and sequence to generate the associated Legendre polynomials both in Excel and Google Sheets.